Okay, so let's start from the firstly our first lecture was about the Bohr model, okay, and now we will discuss about the short questions, okay, the possible short questions. Okay, the most important thing, maximum number of electron in each shell is depend upon the formula, that is 2n square, okay. So according to this formula, if in first shell the number of n equal to 1, so there will be a 2. In second shell there will be a 2 power 2, that will be 4. 4 multiplied by 2 will be 8, and in third shell that will be a 18. 3 power 2 is 9, and 9 multiplied by 2 is 18. The second question was about, this was the first question. Second question is, if the electron remain in the same, all the electron in same energy level or the same shell will have the same energy. Mean all the energy of all electron which are the at in a first shell, if there are 2 electron, both 2 electron will have the same energy. And similarly, in shell 2, the electron will have the same energy. Okay, so because their energy will remain the same, so up till when they remain in the same shell, they will not emit and absorb the energy, because they will be defined as the same energy level. Okay. Third question is about what will be happen when electron move from high to low and low to high. So when electron move from low energy level to high, it will absorb the energy, and when it move from high to low, it will emit the energy. But they will be the same. As the energy will be absorbed, the same energy will be released. Why the same energy will be released? The no question is why the same energy will be released. Because the electric potential, electric energy is a potential energy in the form of in the case of the potential energy. How much work will be done? It will be the same work will be done by again. So when electron move from low to high shell, then when electron will move from low to high shell, then the energy will stored in the form of potential energy. Because the for closed path potential energy work done by for closed path for a conservative force is 0, and electric potential, sorry, please be silent, or electric and Coulomb force is conservative force. That's why the closed path, when it come to initial point again, the work will be 0 and energy will be 0. That means the energy will be the same when it move from low to high and high to low. So that's why the same energy will be met. The energy will not different, because it is a conservative force, and for conservative force, work done for closed path will be always 0, and Coulomb force is a conservative force. Okay, got it? And the next question is, what is actually the work? Is work is depend upon the displacement. The same I have already explained. The work is actually the distance covered under the action of the force, not a displacement covered or a path covered. Distance or path have the same meaning. So work depend upon the path, not a displacement. Okay, so for closed path, the work will be not 0. Okay, so agar question ye aata hai कि what is the work generally work done for closed path, your answer must be the work done for closed path will not 0. But for conservative force, the work done for closed path will be a 0. Okay, got it? So. But in vector, no, next question is, in vector we may measure only the displacement. Or mathematically there is only one way to find the distance between 2 points, is to measure the shortest distance between 2 points. But generally work depend upon the, as I have already stated, the generally work depend upon the distance. Then how the physics or mathematics come override on this problem? The answer is it will be divided, the path will be divided into the small patches, and we localize it. Localize mean the patches become so small, infinitesimal small, and it will behave like a straight line. And then we will sum, and in this way, and this summation will be converted into the line integral. Line integral. So that's the difference between the line. हाँ जी, आप इतना भी जवाब दे दो वो भी ठीक है, मतलब दैट डिपेंड अपॉन अगर डायग्राम ड्रा करने को लिखा होगा, ठीक है, डायग्राम को कहा तो डायग्राम बना तो ज्यादा अच्छा है, और साथ ये भी एक्सप्लेन करता है ना. सो इट्स मीन so we will divide it into the small patches, and then we will localize it, mean path become infinitesimal small, patches will become infinitesimal small, and some of these small patches will infinitesimal small patches will behave like a line integral, because it will be projection of change of dl on dr on the displacement. So that will be the line integral. Okay, and I have already explained in the your lectures. How many vectors have components? कितने infinite. There are different ways to define the component of the vectors. All the vectors which are adding to give the resultant will be defined as a component of that vector. So if any vector may be divided into different parts, so that means they have we may define the component in a different way. Okay. So, but what is how many maximum number of orthogonal components? It depends upon the dimension. In 2-dimension space, they will be 2. In 3-dimension space, they will be 3. Okay. Why vector can't be multiplied with the ये question भी usually आ जाता है. Why vector can't be multiplied with the vector? Why multiplication is not defined in a vectors? Because in matrices form, if we multiply, vector may be represented in the form of the column matrix, and when we multiply a column matrix with the column matrix, then 3 cross 1 row will not equal to column, so multiplication can't be defined for a vectors. Okay. The next question, जी R3 mean वैसे तो different मतलब क्वांटम मैकेनिक्स में इनफाइनाइट डिमेंशन में भी करते हैं, रिलेटिविटी एंड कॉस्मोलॉजी में 4 डिमेंशन से. R3 से मुराद है रियल नंबर में 3 डिमेंशंस, एक्स एक्सिस वाई एक्सिस, ए एक्स वाई जी. आप क्योंकि ज़्यादातर ए एक्स ए वाई ए जी को जानते हो इस वजह से. वैसे ए डॉट बी इज नॉट इक्वल टू बी डॉट ए, तो आर क्यूब में ए डॉट बी इक्वल टू बी डॉट ए है, क्योंकि वो मैं आगे बताऊँ, अभी अगला क्वेश्चन है. ठीक है. Okay. Hello. Okay, next question is if vector can't be multiplied, then what is the meaning of dot product or scalar product or cross product? Answer is dot product or scalar product or cross product are not vector multiplication. That is a misconception. Actually, they are the 2 different operations. Dot product represent the effect of one vector on another vector, and cross product represent the area of parallelogram. Okay. If question is what is the cross product represent? Cross product represent the area of parallelogram. Okay. So for as I have already explained, the work is for conservative force, work for closed path 0. So what is meaning of the potential energy? What is the potential energy? Is it the change in the energy stored in the body due to change in position? No, everything is when we change the position, work always done, but it doesn't mean that is a potential energy or that is a conservative force. Actually, the answer is the work done against the conservative force is defined as a potential energy. Okay. And so when we do work done against the conservative force, then it will be stored in a mass in the form of potential energy. So that's why when we move away from the nucleus, then electric potential difference will be increased. Okay, that's the reason why the higher shell have more energy as compared to inner shell, because when electrons move from lower energy inner shell to higher level, then they move away from the Coulomb force against force, and this work done against this Coulomb force will be stored in the form of potential energy, and their potential will be increased. Okay, so is tarah ka short question bhi aa sakta hai. Why opposite charge attract and same charges repel in Coulomb force? Answer is since force of attraction must be always a negative, and because their acceleration will be toward the center for attraction, and for repulsion their acceleration will be away from the center, that will be a positive. So if two charges are in Coulomb force are opposite, Coulomb force is multiple of the charges, product of the charges. If plus multiply with the plus, then that will be a negative. But if the same charges are multiplied, plus multiply by plus or minus multiply by minus, the answer will be a positive, that will be a repulsive force. But when we multiply opposite charges like plus multiply by minus or minus multiply by plus, the answer will be a negative. So acceleration will be a negative and force will be a negative. So as we have already discussed, the negative force represents the attraction. So that's why the opposite charge will be attract and same charges will be repel. So what are the what will be the gravitational acceleration when we move from low point to high point in the presence of gravitational field, and from high potential point to low? What will be change in the acceleration? When we move from low to high, acceleration will be a negative, and from high to low, acceleration will be a positive. Answer is no, this is a wrong. Because gravitational force is conservative force, and that is attractive force. For attractive force, acceleration will be always a negative. Even if you move from low to high or high to low, the acceleration will be remain always negative, and force will be always remain the negative. Okay, but the path will be different. For high to low, the 3 minus 2, and from low to 2. So there will be the sign of the change in sign due to the path changing, not due to the sign of acceleration changing. Okay, acceleration will be always negative. Okay, and that is true. That is not only true for the gravitational, that is true for all attractive force like elastic restoring force, gravitational force, Coulomb force. All are will be a negative for attraction. Okay, so and acceleration will be always a negative, even if you are moving away or moving toward the force.
Acceleration की direction हमेशा downward होगी ना, gravity के?
हाँ जी, toward the center. Yes, gravity की तरफ, downward. You are right. Okay. So what is the potential energy? I have already explained. The energy work done against conservative force will be stored in the form of the potential energy. So that is the what is the electric potential energy work done against the electric potential energy? So so electric field will be always potential energy will be always F dot dl. Work is always equal to F dot dl. So that will be a QE dot dl. Okay. May we define every energy may be converted into the potential energy, or all energies may be defined as a potential energy?
No,
the answer is no, because potential energy is defined only for the conservative force. Okay. What is the potential? Yes. Potential. What is the potential? Potential energy per unit charge. What is the charge? That is that will be defined as a potential energy. What is the charge? Charge is the extra degree of freedom for any force which is responsible for the force. Okay, like a gravitation, according to Newtonian law, for gravitational force that will be a mass. For electric force that will be a Coulomb charge, electric charge. Okay, so for electric potential we will divide the potential energy with the charge q, and for the gravitational force we will define and divide it with the mass, because mass will be behave like a the charge of the gravitational force. Okay, so potential difference potential will be potential difference potential difference is equal to change in potential energy, potential difference will be change in potential energy per unit charge, electric potential. Okay, what is the actually potential? Potential is actually the potential energy per unit charge at specific point. Mean if you consider that the reference point at infinity, okay, and the and moving from infinity to specific point. Why reference point must be taken infinity for instantaneous potential energy or a potential at specific point? But why we have to take? Because at infinity effect of the potential will be a zero, and infinity is not a measurable quantity, and it means the out of range, means where effect is zero, electric field will be a zero. So the potential at A will be, or potential at reference point, that will be a zero if I consider that reference point at infinity. Okay. Okay. And now the different question, what is the infinity? Infinity is not measurable quantity. No, infinity is a measurable quantity, and it means out of the range. And it defined for different problem, it have a different values as a zero. Both have the same property, and infinity divided by infinity, zero divided by zero, infinity power infinity, zero power infinity, all are undefined. Okay, and their result are the same. For example, what is the next question, what is the 0 divided by 0? That will be undefined. But if 0 divided by n not equal to 0, if denominator is not 0, then result will be a 0. But if n is not, if numerator is not 0 and divided by 0, then answer will be a infinity. So one must be a not 0 to get definite value. If a numerator is 0 and denominator is not 0, then answer will be 0. If numerator is non-zero and denominator is 0, then answer will be infinity. Okay, and if numerator is not 0 and denominator infinity, then answer will be a 0. And if numerator is not 0 and but okay, so that's the different way. Okay. What is the difference between what is the integration and differentiation? When we take a patches infinitesimal small and that become like a curved path become a straight line, then it will be defined as a derivative. And when we sum such kind of the patches is, then that will be defined as a integration. Okay. Next question is what is the uniform charge density? Linear charge density, charge per unit length. What is the surface charge density, charge per unit surface? What is the volume charge density, charge per unit volume. Actually, volume density is usually don't define, because actually in conductor, according to Gauss's theorem, charge will always come out from on the surface. So that's why there will be always a linear charge density. We will use the linear charge density or a surface charge density, and and in this way we may calculate the charge densities. Okay. How may we calculate the area of the surface? Area of any surface if the shape is not regular. Actually, we will divide it into the small patches, and that will be the surface integral, double integral, delta alpha cross delta beta. Okay. We have already proved it. Okay. What is the meaning of electric potential, equivalent potential surfaces? What is the meaning of equal potential surfaces? Answer is the surfaces on which all locus, all points and all points have the same potential. This is one, and all paths drawn on these surfaces will have the same potential. Mean if there is an even curved path, they will have the same potential. Okay, got it? Equal potential surfaces. If we draw a locus or a path on that surfaces, all point on that path will have the same potential. What is the condition for the equal potential surfaces? Yes. The electric field and the surface, angle between the electric field and the surface must be a 90. If they are orthogonal, then that will be a cos theta 90 will be a 0, so then the potential difference will be a 0. Okay, got it? Okay. Okay, now if there is a single charge and there is a plane sheet, then if I draw different point on that plane sheet, will they have the same potential? No, because for single charge, electric field will be a spherical symmetric, and the field will be a radial. Only surface of the only spherical surface of same radius. Every point have the same radius of spherical shell will be equal potential surface. So in the case of plane sheet, they will have a different angle and they will be not orthogonal to each other. So that will be not a equal potential. So different point will have a different potential. Okay, got it? Okay. So for a single charge, the electric so only the spherical surface of the same radius will be equal potential. If the radius is changed, then the potential will be a change. As we move away, then the potential will be increased. Okay, got it? Now the question is, if there is a parallel plate and there is if we draw a spherical shell around the parallel plate, what will be the change in potential? This will be not a equal potential surface, because for plane sheet the Gaussian surface will be a flat surface, and that will be a rectangular symmetric. So that's why I have already discussed it. Okay. In parallel plate capacitor, if we consider the equal potential surface between these plates, all point on this plate, Gaussian plate, will be equal potential. So if we draw even curved path on this, or if we move the point in this plate, the surface, the potential will remain the same. There will be no change. The potential will be changed only when we move a Gaussian plate from first plate to second plate, as in the case of spherical capacitor. Okay? Okay, please be silent. For positive charge, electric field will be positive charge, electric field will be outward, and for negative charge, electric field will be inward. Okay?
Yes, sir.
That is a very important point. Okay? And electron always move from electron always accelerate from low potential to high potential, and a proton is always accelerate from high to low, and deceleration, for deceleration it all will be inward. Okay, got it? For parallel plate capacitor, we always consider the infinite charge distribution on infinite length plane sheet. But infinity, how we practically get the infinite length plane parallel plate? Okay, the answer is we will consider only the small part of this parallel plate, and so electric field for this small part, charge will behave like the charge is distributed on infinite sheet. Okay, and the same procedure or method used to develop any type of the devices where we require infinite. Okay. Why in the case of parallel plate capacitor we consider the electric field from both plates, but in the case of spherical charge capacitor we consider the charge distribution only on one spherical surface? What is the reason for this? Answer is, for parallel plate capacitor, the Gaussian surface between the parallel plate will experience the electric field due to both sheets, positive distributed sheet and negative distributed sheet too. Okay, but in the case of spherical capacitor, the electric field passing through the Gaussian surface will be only due to the surface enclosed by this charge enclosed by this Gaussian surface, and so inner surface will be included. The electric field due to outer surface, the electric field passing through the Gaussian surface will be a zero. Okay, because the charge will be not enclosed. But according to Gauss's law, electric field will be always electric flux will be always equal to Q enclosed divided by epsilon naught. That's the reason. Okay. In the case of parallel plate capacitor, why we consider only the small part of the charge distribution on parallel plate to find the electric field? Because answer is because according to Gaussian we have to consider the charge enclosed, and we consider a very small portion to consider the infinite sheet. So that's why we will consider only the charge distributed on charge enclosed by that Gaussian surface. So that's why this will be charge will be equal to charge density multiplied by the area of Gaussian surface. Okay, not area of charge distribution surface. The next question is, why, if the charge distribution is infinite, is distributed on infinite sheet, why we are considering only the electric field due to the small portion? The answer will be the same, because we have to consider the charge enclosed by the Gaussian surface. Okay.